So this is lesson 3.4 in elementary algebra. Let's make it 3.4a. I'm sure that's what we're going to run into with this one. And the name of this lesson is the slope of a line. All right, so a slope. If we have, in fact, let me get a graph out here so we can look at that as we're going. Let's see, where is it here? Okay, so there is our graph. And if we have a line, let's just stick it right here. All right, it has a certain slope, a certain steepness about it. Okay, how fast it goes downhill. Some of you psychos would ski on something like North Face at Alyeska that's more like this. Some of you would ski on this. Some of you, like me, would kind of do the bunny hill thing. And so each one of those three lines has a certain steepness. The black line obviously has the less steep slope, and then this one, and then this one. Okay, so one of the things with the slope is, in defining the slope, is how steep that goes. And we use a number to represent how steep something is. And the way it works is the smaller the number, the less steep it is. The bigger the number, the more steep it is. Okay? So that's one of the things that we're looking at. Another thing that we're looking at when it comes to slope is, and let me get green ink here, is whether the slope, or whether, from left to right, goes downhill or goes uphill. So those are two things that we're looking at. We're looking at how steep the hill is, and whether it goes downhill from left to right or uphill from left to right. All right? So those are the two things that we're looking for. Again, I said that the steeper the slope, the bigger the number is. Whether it goes downhill or uphill, we decide whether or not that number is a positive number or a negative. So the number decides how steep it is. Whether that number is positive or negative determines whether it goes downhill or uphill. Okay? So if a slope goes downhill, we're going in a negative direction. So you might want to write that down. It's negative. And if we're going uphill, we're going in a positive direction. Okay? So those are the two things that we're doing as far as slope is concerned. And slope is basically a ratio. It's the ratio of one number to another. Now, what are those numbers? Well, let's get rid of this graph and get another graph up here. And there's our numbers. So we determine whether or not, or how steep our slope is, or what our slope is, depending on the ratio of this number, how far it is between here, that dot and this dot. And see, this corresponds with that. So that's called the vertical change. The distance from here down to the next dot, which is right here, another dot on the line, that distance is our vertical change. And let's just say, for instance, it's 8. Okay, I'm just grabbing a number there, that distance between here and here is 8. So our ratio then is our vertical change, our 8, or our rise is what it's called, over our horizontal change, and let's say that this is 16. All right, so that is 16. So that ratio is the slope, and 8/16 reduces to 1/2. So the slope of that line right there is 1/2. Now it's positive 1/2 because from the left side to the right side we are going uphill, not downhill. So our slope is positive. So our distance here over our distance here will always tell me the slope. Okay? And this is called the rise over the run. And they do that when they measure steps and when they determine the steepness of a roof on a house, etc. All has to do with slope. So rise over the run. Or they have the vertical change. Okay, when you're doing vertical, you're talking about y. And when you're doing horizontal, which they are talking about here, you're doing x. And there's a symbol in math and in science that they use for change, and it is a Greek letter called delta. It looks like a triangle. So that means the change in y over the change in x. And we'll get to this in just a minute, what that means. What does the change mean? You just gave me a number here and put it over a number here. Well, we'll get into what that vertical change is here in a minute. So let me erase all of this, and we'll get into the whole vertical change thing. All right, so let's say that this point here is point, now let me change it. Let's make it 0.53. Okay, so we went over 5 to here, and then we went up 3. Okay, so that's where that point is. Let's say that this point over here is 0.11. Okay, so we went over 1 and up 1 to get to that point. Okay, so those are our 2 points. We're trying to find out our slope. Well, how far is it from here to here? How far did we have to go to get up to there? Well, if our second number is 1, that means we went up 1. This second number is 3, so we went up 3 to get here. So the distance between here and here, from here to here, is going to be 2, right? It's going to be wherever we are with the y and wherever we are with the y there, the difference between those two. So we could write it as 3 minus 1 equals 2. That is the vertical change. That is the change that we made from going from here up to here. There's a change of 2. Okay, vertical change is always the distance from one of the numbers, one of the y's, let's call it y2, just to say that it's a different y than this one. So y2 minus y1, that's the vertical change. So we went from y2, the second y, it's 3 high, minus the first y over here, y1, which was 1 up. Okay, so 3 minus 1 gives us 2. Let's do the same thing over here. All right, we already determined that this x is 1 and this x is 5. So the vertical change, or the horizontal change, would be how far we went to get here. We went 5 minus how far we went, how far we went to get here, which in this case is 1. So our vertical change is x2 minus x1, 5 minus 1, is 4. So this length is 4. Okay? It took us 5 to get all the way here, and it took us 1 to get here, so the distance between the 1 and the 5 is 4. Okay? So what we've got is our rise, which is our rise. Let me see if I can write this. Our rise over the run, our vertical over the horizontal, equals, that's the same as our change in y over our change in x, which we did right here. This is our change in y, this is our change in x, which also equals, you're going to have to just get used to doing these and understanding where this came from, and it's going to be a little confusing maybe at first. Okay, so one of the x's minus the other one of the y's minus the other one, and the y always goes on top, the x always goes on the bottom. So our change in y we said was 2, our change in x we said was 4, so our slope is that reduced, which is 1/2. So that's our slope, and we went from left to right, and whenever we go uphill, that's positive, so our slope is 1/2. And what's really weird, they got a weird sign for slope. So instead of writing slope over and over, the symbol they use for slope is the letter M. I have no idea why, but the slope is represented by the letter M. So the slope of this line that I have right here is 1/2. Okay, tells me my ratio, tells me it's not real steep, and it also tells me that it's positive, so it goes uphill from left to right, and that's what that does. All right, so if you look at the bottom of page 220, it gives you the definition of a slope. And hopefully my definition that I gave you as we kind of walk through this is going to help. So I'm going to go ahead and get rid of this, and we're going to practice some. And hopefully as we practice, the theory that I just scribbled on here will start making sense, and you'll be like, oh my gosh, this is so easy. I've got this now, in spite of Gary being so confusing. All right, so let's go ahead and bring our graph back up here. And for example, number 1, they said find the slope of the line between the points 1, 2, and 3, 5. All right, so let's go ahead and graph that. We don't have to graph it, but let's do it anyway. 1, 2, and 3, 5. Okay, so there's our line. Notice our line is pretty steep and it goes uphill. So because it goes uphill, we know it's going to be positive. And let's go ahead and do this. All right, the formula on the bottom of page 220 says that the slope, which again we called m, is rise over run, which is, and again we already did this, minus y1 over x2 minus x1. All right, so let's look at what we have here. How far is it from here to here? 1, 2, 3. It's 3. So the distance of my y is 3. That's my rise. And my run is going to be the distance between here and here, which is 2. So there is my slope, and it's positive. Okay. Now, if you did it without graphing, let's do it without graphing. Let's pretend that our graph isn't here at all, and we are going to just figure it out given the numbers right here. Okay, what does it say? There's our formula. Our slope is equal to y2. Doesn't matter which y you pick. You can pick this to be your y2 or this to be your y2. It doesn't matter. But if you pick this to be your y2, then down here where it says x2, you have to pick this number. So if this is your y2, this is your x2. This is your y2, this is your x2. But it doesn't matter which. So let's go ahead and take 2 as our y2 minus 5 as our y1 over 1 as our x2 minus 3 as our x1. So it's 2 minus 5, negative 3. What's 1 minus 3? Negative 2. And 2 negatives give you a positive. So I did not even use the graph, and I came up with the same slope. All right, let's say I switch those numbers around just to show you that it doesn't matter. Let's say instead of using our 2 as the y2, let's use the 5. So we have 5 minus 2 over 3 minus 1 equals 3 over 2. So there I get my positive slope of 3 over 2 again. So it doesn't matter which one you use. So that gets us through example 1. Next video we'll start on example 2.